looking at problem number 1. Now remember, when we do these problems, when you're doing a multiple choice test, you want to work smarter, not harder. So you don't always have to do all the work first and then look at the answers. Let's do the first step and see if it's enough to eliminate some answers, and then we'll do more if necessary. Now, when you have a list of numbers, it's mandatory that you do what with that list? Arrange them in order from least to greatest, okay? I saw a lot of papers where people didn't write that down. I noticed a correlation between the people who did a lot of work on their paper and their test scores, okay? Not always, all right, but it was a good indication of what a person was going to make on that test when I saw how much work they did. So let's go ahead and, if you guys have that list already on your paper, someone read the numbers out to me. Okay, 45. Okay, so now we have the numbers arranged from least to greatest. The smallest number will give us the minimum, correct? So let's see, the minimum is 45. So let's see, minimum, no minimum even listed. I haven't done it yet. The minimum here is 50, so it's not that. I don't know if it's not A. I really can't eliminate A yet because all I'm doing is looking at minimums. Okay. We know it's not C. Here the minimum is 45. Okay, the maximum is 69. And did anyone find the median? Okay, 58.5. So what about, let's see. What about the lower quartile? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6. So 1, 2, 3. So what's the lower quartile? 53. The upper quartile, 1, 2, 3, is 62. Okay, so this is the answer D. All right. So it was a little tricky because A had some different information in there. So number 2, list a set of data values that can be represented by the following box and whisker plot. What's nice about these lists here, guys? They're already in order. So without any rewriting anything, you can really identify your Q1, Q2, and Q3 right from here. The mins and the maxes are the same for all 4 lists, so that doesn't help us eliminate anything. So now let's see. So our Q1 is 6. Our Q2 for mean, or median I should say, is 9, and our Q3 is 15. Everyone agree? Okay, does anyone have a question about how I arrived at those numbers? All right, so now let's look at this list. 4, 6, 8, 1, 2, 3, 4, 5, 6. All right, so 8 plus 11 is 19. 19 divided by 2 is 9.5. So that does not give me the correct median, so it can't be A. Does everyone understand how I eliminated A? I found the median, and it was 9.5. I could have found, well, take a look at this. Q1 works, and Q3 work, okay? But Q2 did not work, so that's why A was not the correct choice. Is that clear? All right, let's look at B. So let's see, 7 plus 11 is 18. 18 divided by 2 is 9. I'm liking that. Q1 is 6. Q3 is 15. That's the answer. My work is done. Okay. All right. Number 3, the histogram shows the math test scores for students in a high school. What is the total number of students in the class? So I saw some of you did this on your paper. What's a nice way to figure out what numbers we're going to add together? How many are in this column? How many? 3, so I can put a 3 there, and this is 5, this is 0, this is 12, this is 8. Why am I doing this, guys? Why am I listing those numbers there? What do I need them for?
What are you listing
Yeah, so what am I going to do with them to find out how many people? I'm going to add them all together. So if you add 3 plus 5 plus 0 plus 12 plus 8 plus 2, then you get what? 30. What? Can you see? All right. Good job. So far, so good, everyone? All right. So, forgot to clear this page out. So, for this one, for number 4, um, some people did choose skewed left for this one. All right. And skewed left means that most of the data is going to be clumped over here. All right. And so this wasn't really skewed left. This was unimodal. Had that one peak right there. All right. So could seem a little subjective, but the answer was D. Any questions about that? All right, so I didn't erase from last period, but we can still talk through this. So it says use a two-way table to answer the question. So 12 plus 8 is 20. 4 plus 11 is 15. 12 plus 4 is 16. And 8 plus 11 equals 19. So I needed the totals because I needed to figure out what to divide by. So take a look at this. The question always comes up, are we dividing out of the total number of people or are we dividing out of some other number? So you have to read the question carefully. So it says, what percent of students who studied more than 2 hours? Pause. The percent of students who studied more than 2 hours. So that word of usually tells us what our denominator is going to be, whatever comes after of. So students who studied more than 2 hours. So where are those people? Okay, students who studied more than 2 hours. Altogether, there were 15 people who studied more than 2 hours. So that was my denominator, right? And then out of those, I'm looking at only at the ones who studied independently. That was 4. And I just divided those. 4 divided by 15 is 26.7. Okay. Any questions about that? Please ask me questions. If you don't understand, even though I may have made it sound like it was simple and you still don't get it, you better say something. I do not mind. Okay, everyone's good? All right. So it says the total number of text messages, the number of text messages 10 different students sent in one day is shown in the box plot below. So what I did here was I identified Q1 and Q3 because that's how you find the interquartile range. It's Q3 minus Q1. So that's an important formula. Hopefully you already have it on your index card or you're about to put it on there. So then I had to look at my box and whisker plot. So that was nice that we had that so we didn't have to really do any work. I just identify my Q3 here. That's 14. My Q1 is 8. 14 minus 8 is 16. Any questions about that? You processing, Ryan?
Yes.
All right. Did it work? Okay, good job. All right, anybody else have a question? All right. So there are no questions, so I guess that means that people were getting these problems correct. All right, so I think I went clear. Okay, so for number 7, I think that was a pretty straightforward question. Basically, you're just looking, again, you need to find the lower quartile. So how do we identify that that's Q what? Q1 is the lower quartile, so that's that left side of the box. And so which one of these was the farthest over? That would be class number 1. Right? In which interval does the upper quartile fall within the histogram? So basically, with this right here, the upper quartile is going to be to the right of that peak, and the lower quartile is going to be to the left. So I think just about everybody got that one right. What percent of students who live off campus are men? So are we looking at everybody in the entire group or just a specific group, guys? Yeah, which one in particular?
Men off campus.
Okay, right. Well, not men off campus. Okay, see, remember what I said earlier? Whatever comes after of tells you what the whole group is, what the denominator is. So just the students who live off campus. That's going to give us our denominator. And then out of those, I want to know which ones are men. Okay? So that's a different question from an example I'm going to give you in a moment. So anyway, now out of those, so how many people live off campus? 7,768. And how many of those are men? 4,010. And so when you divide those, I think you get 27.1. Okay, take your word for it. Okay, I don't have my answer key in front of me. What? Any questions about that? Now, this is different from me asking how many of the students are men who live off campus? How many of the students are men who live off campus? Well, how many men live off campus? That's 4010, but I would divide that by 14,808. That's a different question.
Yeah.
Okay? Okay. So that...
Yeah.
Is it 51.6? I don't know. I didn't do the math. Okay, guys. Hold on. Let me check. I just trusted you guys to answer. So this 4010 divided by 77. Yeah, okay, this is a good lesson. So it's the answer for number 9 is indeed C. Okay? Now, let's think about this. I just circled B. Someone called out the number and I just circled it, okay? But think about this. 4,010 is more than half of 7,000. That's almost 8,000. So I should have said, hey, wait a minute. That can't be right because this should be closer to 50%. All right? So I wasn't using my analytical skills to make sure that that the answer makes sense. I just circled it, okay? But the answer is C. That's what I used to in my answer key. Yes. Okay. Is it urgent? Okay, hold on. I have to pause everything. Keep it moving. Okay, so now that was number 9. So next page, number 10. All right. So I think that's pretty obvious that this is a strong positive correlation. If it was a little more horizontal, it'd be a little weaker. But this is strong. That's strong. So it's A. All right. Number 11, the number of text messages. So the same text message scenario, but new question. What is the maximum number of text messages sent? You're just reading it. Where's the max? It's that very last one right here. Okay. All right. So that is 20. B. And thanks, guys, for catching my mistakes. You're doing a good job. Which value in the data set below is an outlier? Now, I think it's safe to say, although a lot of people selected 8, there's really no outlier here. All right? There's no outlier. But there is an actual formula, so I'm just going to go through the process. It's a little painful, but I'm going to go through the steps of finding an outlier. And so you can see it, because it could be that on the one on the test there is an outlier, and you need to know how to find it. So the first thing I need to do is, this is the same set we had before. So what is that? 3, and then I think there were 3 4s or 4 4s. And 3 5s and 2 8s. Okay, so same list from before. 1 2 3 4 5 6 7 8 9 10. So 1 2 3 4 5. So here is my That's my Q1 and Q3. Now, the reason I needed to find Q1 and Q3 is because I need my IQR, and that's going to be 5 take away 4, which is 1. So my IQR is 1. So here's the deal. If there's a number that's bigger than 1.5 times the IQR, it's an upper outlier. If there's a number, plus the max. If there's a number that is less than 1.5 times IQR minus the min, okay, then all right, then it's an outlier as well. So what's our IQR? IQR, guys, what is it? Class, what is the IQR? We just found it, okay? It's 5 take away 4, it's 1. That's the IQR. I need you guys to talk, otherwise that makes me think you're not paying attention. Okay? We got to go through this. So the IQR is 1. So we're going to do 1.5 times 1, and we're going to add 8. That's 9.5. Are there any numbers in my list that are bigger than 9.5? No. So there's no upper outlier. Okay? So now we're going to do 3 minus 1.5 times 1, which is 1.5. Are there any numbers in our list that are less than 1.5? No. That's proof that there are no outliers. Okay? So that's the long way of finding out what we already know. Okay? Outliers are far away from the data. Okay? They're not going to be close. 8 is relatively close to the data. Right. Number 13. So once again, we have these numbers. Same numbers. It says which value in the set is the mode. Clearly 4 is the mode. We have 3 4s. Now, causal and correlation. Remember, causal, it's directly responsible for causing the result. Okay? Correlation, it just happens to be a connection. You notice that when this thing changes, this thing also changes. That's correlation. Doesn't mean that it's causing it. Okay? So, the temperature changing and getting warmer, people sell more ice cream when it's hot. Okay? But the heat doesn't cause people to buy ice cream. Okay? It's not the thing that, because you can choose to buy ice cream or not to buy ice cream. Okay? There's a correlation between the two. You have to make a decision to do the next part, to go actually buy the ice cream. So therefore the heat is not making people buy ice cream. Otherwise everyone would be in line for would have been buying ice cream like it was 90 the other day. Okay? We all would have been walking around eating ice cream. All right, but yeah, I don't either. So, but on the other hand, if you're driving a car and you're using gas, okay, so the longer you drive, that's causing the amount of gas in your tank to decrease. There's a direct connection between your driving and the amount of gas in your tank. That's causal. So number 14, C, is the correlation example, but number 14, D, is the example of causation, because when you exercise, that burns calories, because activity requires energy. All right, and so when you're using energy, you're burning calories. So are there questions? You need to make sure you know the difference between causal and correlation. So that's something you can easily Google if you want to find some videos and things like that. Now, for whatever reason, my copy of the quiz was missing the final pages because we kind of tacked that on later, and so it wasn't in my document, so I have to kind of do the rest by hand. So we're on number 16. We're going to go through that. Page number. Where's that? Okay, so very quickly, let's look at number, I just need to scroll over so we can get to number 16. So for number 16, This is that famous problem. We've been looking at this problem for quite a while. Some of us are guessing. We're not even trying to do the math. Um, but the worst thing is we've had this problem like 5 times probably, and people still got it wrong. So you should be taking notes. Wake up, pay attention. All right. So if you were going to just work backwards from the answers and figure out what the correct one was, then when you plug the numbers in one at a time, you should get the same thing on both sides. But otherwise, if you're just doing the work, you want to make it equal 0. You could do the quadratic formula if you like. Negative 6 times 4 is negative 24. Negative 6 plus 4 is negative 2. But here's the problem. Some people were taking these numbers and using them as your answers. But you have to remember that you're really supposed to take the opposite. Our shortcut is to take the opposite of those. The reason why is because we're setting n minus 6 equal to 0 and n plus 4 equal to 0. So I have to add 6 here and subtract 4 here, and I get n equals positive 6 and equals negative 4. So most people selected the opposite answers. All right, so the correct answer for that would be A. This is number 16. Sorry, Michelle. Leave the door cracked when you guys go out. Okay. Number 7. Anyone writing? Sorry. Anyone still writing that? Going once, going twice. Okay. Go ahead and write. Okay. You all done? You're good? Okay. Number 17. Y equals 2x squared minus 3x to the 5th plus 5x. Ladies and gentlemen, we should not be getting this problem wrong. Let me tell you why. I think what some people are doing is they're just only looking at the first number, and they think that if the variable on the first term is a 2, then it doesn't matter about anything else. It's automatically a quadratic equation. And that is just not true. All right? What messes it up? That 5, that exponent of 5. You have to look at every term. And if any one of those terms is anything other than a 2, okay, then it cannot be quadratic. All right? You have to have the 2, and then the other ones have to be less than 2. So this could be just an x, and really or there could be no x at all. So this is not quadratic. The answer is D for neither. And the reason why is because of that 5. That keeps it from being quadratic. Any questions about that? It's okay if you have a question about it. Please ask now. Yes, madam.
So, are you saying it was neither?
Say that you said the answer is neither.
Because I have 2x.
Okay. Yeah, well, because it can't be linear, because linear has a degree of 1 only. Okay? And then, what was the other choice? Exponential would mean that the exponent was a variable, so it wasn't exponential. So those were our only choices, so we have to go with neither. Okay? Good. Number 18. Another familiar problem. And in fact, these problems that basically 16 through 25, get off your phone, these are all problems that have been missed frequently. So we want to see you guys get these problems correct this time. So now, we have here a school that has an average attendance of 950 students. All right, that's your starting amount. We know that it's decreasing, so it's going to be 1 minus. We know that the rate of decrease is 0.5%, so I'm going to move my decimal point over twice. And I'm looking at it for 3 years, and when I do that, I get 936 students, which is C for number 18. For number 19, use the two functions to choose the best statement comparing the graphs to each other. So 19 and 20 are similar. So this gets, some of you guys need to take some good notes on your note card so you can remember how to do this, you might want to find that your present from Miss Davis. What's the present from Miss Davis? What color is it? That purple sheet. Okay, that was a treasure. You should save that because you're going to need that again in the 11th grade. When you get to that in the 11th grade, you can pull out and say, "Oh, I already have these notes, teacher." Okay, and so you can show that you learn that and you'll remember that because you're always going to remember that when you got that lesson from Miss Davis. So for number 19, use the two given functions to choose the best statement. So the original function was y equals 2 to the x plus 2. If only I could write 2 to the power of x plus 2. And then the new function is y equals 2 to the x plus 5 minus 4. So two things have changed. The exponent has changed and this number here has changed. So it looks like we subtracted 5, and then to go from 2 to negative 4, what would we have to do? Subtract what? What number can I add or subtract from 2 to get negative 4? Yeah, 2 minus 6 is negative 4. So now, there was something special about changing in the exponent. What kind of movement is that? Vertical or horizontal? Horizontal, okay? Remember, which axis is the x-axis? It's the horizontal axis. So that's how you keep it straight. If it has to do with x, that's horizontal. So that means that we have also to remember that there's something special. We do the opposite. So minus 5 normally makes us think of going to left, but we're really going to do the opposite. So it's going to be right 5 and down 6. So that would be D for number 19. Questions about that? Did I choose? You know what? I'm not even which one is it? Left 5. Is it D? Oh, did I write it wrong? Okay, I wrote it wrong. So, okay, so this is plus 5, but it's left 5, right? Oh, did I write the wrong one? Okay, I wrote my words wrong and selected my answer correctly. Okay, I know what happened. I was going by what I wrote here. I wrote this incorrectly right here. I was thinking about the left. So anyway, so this would be left 5 down 6. Thank you. Okay, I confused myself because I put a minus 5 here when I should have put a plus 5 here. All right. All right. So to be clear, so I think I may have messed you up on this one. Does everyone understand? So what I was doing here was just saying to myself, what do I have to do to this to make it look like that? And I should have put a plus 5. What do I have to do to the 2 to get a negative 4 minus 6? All right. And when I have a plus 5, I have to do the opposite. So that's why we had to go left. So I had everything kind of reversed. My apologies. All right. Number 20, similar situation. So our original function is x minus 9. And our new function, we want it to shift up 2 and 3 units to the left. So in order to go up 2, I would have to add 2 to this. And to go 3 units to the left, I have to do the opposite. So if I'm going 3 units to the left, I really am going to add 3. Does everybody agree with that? So that becomes x plus 3 minus negative 9 plus 2 is minus 7. So that makes me go left. Anything to do with x is horizontal, and I do the opposite. Inside parentheses, the opposite, outside the same. And that tells me to go up or down. So it's negative 7, so it's down 7. What's that answer? D? Okay, thank you. Thanks for keeping me straight, you guys. You know I always need help. All right. Any questions about that? Going once? Going twice? All right. So, 21. Hi. I think 21 is kind of self-explanatory. Remember exponentials, that hockey stick or J-shaped or boomerang-shaped curve? And the only ones that came, well, A and C were both exponential, but the growth means it's increasing, so it had to be A. Number 22. Now, you have to be careful. There was a typo in here. There was rabbits and squirrels, but we're talking about rabbits, okay? Hopefully you're able to work through that. The starting amount is your A. That's what goes on the outside. And then your rate of increase is tripling, so that goes in parentheses. And then that's your exponent. All right, so what's that answer? C? Okay. I may have marked your papers wrong on that one, so I'm going to give you guys the points on that one. I think I flipped it where I was making my key. Number 23, the correct answer is D for number 23. So when you are looking at a real life situation where you have something going up into the air and coming back down, you have this vertex, that's the vertex, and this is always time and height. So the vertex, this could be the max or min height, depending on if it's open upward or downward. But the vertex gives you time and the amount of time it took to reach the maximum height. And so that would be for number 24, 23, that would be D. Okay, almost done. 24. Which function shows f of x equals 3 to the x being translated 5 units to the left? Again, so we're giving you guys a lot of these because these were missed a lot. So if I'm trying to shift this to the left, where am I going to put that number? It's going to be in the exponent or down below? Class? If I'm trying to shift it to the left, am I going to put that number with the exponent or down below? With the exponent. Remember, the exponent shifts it left or right. Anything in this situation, it's got to be with the x here. And the x is in the exponent. So it's going to be 3 to the x. I'm trying to shift it left. So am I going to do plus 5 or minus 5? Plus 5. Okay? So that's plus 5, boards off a little bit. So that would be what, B? So the plus 5 has to be raised because the x is in the exponent. And then the very last question, number 25, the function graph in this coordinate grid shows f of x, the height of a drop ball in feet after its x bounce. So after its first bounce, so you look on the x-axis, and on the x-axis you're looking for 1, and then you look to the y-axis to find the corresponding height, and it's right here. Okay. So after the first bounce, it's at a height of 10 feet. So here's the 10 feet, and I go down here, and I find the 1, and that gives me the answer. That's A. All right. So there's a little class time left. You should use these 10 minutes to work on your note cards. Go over. You might want to come and ask individual questions to me and Miss Davis if you're missing things. Okay, so work on your next cards. Help each other out. Yes. Yes. If you need one. You can ask her. I'll be right back. If you're missing your index card, I have extra ones right there. Yes. 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 Oh, very good. Make sure you put your glasses.
That's not the same way, it's just the way it's this part of it.
It is.